Good morning, everyone. Happy Friday. I just wanted to share something with my fellow hobbyists and fellow engineers out there that are looking to control something that's uh, like a 12-volt motor, 12-volt DC. And so I wanted to show off this guy. By the way, I'm Tim. Good morning. And so I wanted to show you this little motor driver that you can control with a Raspberry Arduino or whichever you want to use. Um, you have it's called a motor driver board, and it's great for, you know, like a quick project. It's fairly cheap. It's $8.99. You can get it at a hobby shop or just go on Amazon. But I wanted to go over real quick. Um, your input voltage is 5 volts. If you can see right there, you can use an input voltage of 5 volts or 12 volts for your projects. So that means you can put 12 volts on this side, or you can just control with 5 volts, which is a great control voltage. Well, actually, let me back up here. This is the actual applied voltage. This is the voltage going out to your motors. See, output 1, 2, 3, and 4. So if you're using like Lego motors or like just little small DC motors, I know like the Lego NXT motors run off of 9 volts. You can even run them up to 12 volts. But this is great for your Raspberry or Arduino projects. This is going to be control pins from the Raspberry. And this is going to be your applied voltage. This is going to be the voltage driving your source. Now, what these input voltages would do is turn on and off these motors. And when you have output 1 and 2, this can actually be a motor for one direction and the same motor for the opposite direction. So if you turn on, so I'm trying to zoom in real quick, try and get it to focus. So you have output 1. That would be the one side of your DC motor, and that would be side 2 of your other DC motor to run in the opposite direction. So if you turn output 1, your motor would go one direction. If you turn on output 2, the motor would go in the opposite direction. If you turn them both on, it just wouldn't work. And then you would have the same thing for a second DC motor that can be powered off of 5 volts or 12 volts. Most of the DC motors I use are run off of 9 or 12 volts. So this would be your second motor. So this would be motor 1, this would be motor 2. And the same thing, output 3 could be clockwise direction of your motor if you turn it on with your input voltage, and also the opposite direction of output 4. So you can control with 2 motors, both directions, using that run off of 9 or 12 volts, or 12 volt max, and you can control that with an input voltage of 5 volts. So it works great. I love these little guys. You can see it right here. There's the picture. Now you do have a jumper, and this jumper must be plugged in if you're going to only apply 5 volts from your source. You take the jumper out if you're going to run 12 volts. So if you got 12 volts going in, 12 volts going out, take that jumper out. If you got 5 volts going in, correction. If you're just going to run, well, I would say just keep that jumper in, because I actually used the 12 volts, and I leave the jumper in and it controls my 12 volt motor. So I think that jumper is actually tied to, you're going to control this. Now, if you don't have an Arduino or Raspberry, this is great because you have 5 volts and ground. So really, if you have 12 volts coming in here and you jumper your 5 volts to these inputs, all it's going to say is, I got 5 volts here, and I'm going to turn on these 12 volts whatever pins. And this is 1, 2, 3, 4, so that'd be output 1, 2, 3, 4. So if you don't have something to control it, you just want to turn on 12 volt source, you would just you take a jumper that would take the 5 volts to that, and really you're just making a circuit. You're just turning that on, saying, hey, I got 5 volts in, or I got 12 volts going in. I'm just gonna turn this on when I jumper it. So you would just go jumper to it. Now be careful with these enable B and A and B here. For 1, 2, 3, and 4 to work. So 1 and 2 needs you want it to work. You would have to enable this side with a jumper. So put a jumper here, enable 1 and 2. That would actually enable this side, and you put a jumper on the far end, enable 5 volts, you would activate this side. So so what I would do if you're just working from scratch, put your motors here, put your motor wire, both wires, one wire here, one wire there, like white and black or black and red or whatever. Same thing here if you're going to control the 2 motors, and put your 12 volts. If you're going to put like a 12 volt wire, put your positive on VCC, which is, you know, positive, and then put your negative on ground. Now, here's the thing I learned. If you are using a Raspberry and or a Arduino, your ground, you must have a black wire. So you're going to have your positive and you're going to have your negative. You want to have a second black wire running from your ground to the ground on your Raspberry or your Arduino. This is just a common ground. So if you don't have that second black wire going from ground to ground on your Raspberry to here, it won't work. Same thing with Arduino. So make sure you have a wire going here. I rarely use the 5 volts. Because I use 9 12 volt motors, I use the VCC ground with a 12 volt. Now, quick thing, which is very awesome to have, and a lot of people don't have power supplies, but get an adjustable power supply. See this slider? You have 5, 3, 6, 7, 9 volts. This is great when testing. Powering up, I would suggest starting all the way up at 9, 12 volts when you're doing this for the first time. Gradually walk it from like 5 volts up to your desired voltage, just to make sure you don't pop anything. You probably won't, but it's just it's my little thing of being cautious. I always slowly increase voltage to its desired voltage. So like the Lego NXT motors, they run off of 9 volts. So I'd gradually walk 9 volts. And surprisingly enough, they don't really have to, 9 volts is ideal voltage for that type of motor, but they can run off a 6 volts. There is a minimum maximum voltage for those motors, just like most motors. You could probably run it off of 6 volts and it worked just fine. You can run up to 12 volts and it worked just fine. It's that threshold range of a minimum and maximum voltage range, but 9 volts is usually optimal. So anyways, just make sure when you wire your adjustable power supply to your motor shield, it's also called an H-bridge. It's an OSEP H-bridge. Just when you wire it up, make sure you have your polarities right. When your polarity is right, you have positive going to VCC and negative going to ground. The little red light will turn on, and I'll show you on what I have over here, my existing Lego projects. I have 3 of them linked up right now. When you turn them on, they will light up red if it's the right polarity. And like I said, slowly walk them up to like 9 volts. So first, if I wanted to check my polarity on these, just start at 5 volts, make sure the little red light comes on. If the red light doesn't come on, swap your wires if you're new to hobbying or engineering stuff like this. So a little red light comes on, you know your polarity is right. And as you can see here, like it's kind of hard to see with that green light, but I have a Raspberry Pi, and I have my ground going from I have my ground wire going from the ground to the Raspberry, so they have a common ground. Otherwise, it won't work. That's my motor. There's one motor side, and there's the other motor side. and I have 6 of them, so that means I can control 1, 2, 3, 4, 5, 6 motors both directions. So I can control 6 motors that can go in and out. And so I buy these up anytime I get a chance to go up to the hobby shop or order on Amazon. They're about $8.99, less than $10, and they are amazing. I mean, they are so durable. I ran them up to 15 volts, and it still kept on trucking. These are great. Like, once again, I just want to reiterate that these are great for projects where the Raspberry Pi and Arduino only put out 5 volts. The Raspberry, I think, only puts out 3 volts or 3.3 volts. So you don't get a lot of power coming off these controllers. But when you control these pins, you can control 9 to 12 volts or 5 volts or whichever you want to do. 12 volts is your max range that you can control with these DC, not AC. So just want to be clear. DC motors, you could do stepper motors. You could do where it does like a pulse width modulation. But really, actually, yes, you can do pulse width modulation with little stepper motors. This is great. If you don't want to run off the Raspberry Pi, I do suggest to run your stepper motors off of here, because you can burn up a Raspberry Pi. Arduinos are a little bit more rigid, but if you had a motor and you turn the armature, you can induce a voltage that would go back to your Raspberry Pi and blow up your Raspberry Pi, because it only puts out 3.3 volts. So when you turn an armature, you induce a voltage, and it could blow up your Raspberry Pi. I haven't done that yet, but just word of caution. You can run a little stepper motor off a Raspberry Pi. That's fine. It will work just fine. But when the armature actually gets pushed or manually moved, it could blow up your Raspberry Pi. So these are great for stepper motors as well. And I suggest if you're going to use something that is going to be pushing or pulling or driving a motor, or that this would be the best way to go. So, worst case scenario, you blow up this $10 little H-Bridge OSEP motor driver than your $40 Raspberry or your $20 Arduino. So always it works great. So I just wanted to go over with you guys. Happy Friday morning, and definitely check these guys out if you want to do like a quick little home project. I use them for camera systems at home. I use them for controlling lights at home, like LED lights. You can control LED lights with Raspberry or Arduino, standalone, but I like using these because I also control the motors. So definitely a cool thing to have if you're trying to control anything that's 5 or 12 volts. If you want to control something like AC, that's 120 volts, like your incandescent lamps and not so much an LED, I would suggest to use a relay board. There's plenty of relay boards online that will take the DC input from a Raspberry Pi or Arduino, and with a built-in transformer, it will step it up to control that 120 or 110 volt lamp or whichever you want to use. But definitely awesome thing to have. These guys work just great. They're cheap, they're rigid, and if worst case scenario you blow one up, you lost $10, where you're not losing like I said, a very expensive controller like a Raspberry Pi or Arduino, or even a PLC if you're trying to use PLC, which some PLCs, I don't want to get too much into it, but PLCs can control AC voltages up to 110 to volts and all that. But like I said, the worst feeling in the world is when you blow up your Raspberry Pi or Arduino. I haven't done it yet, but anyways, I would feel better if I blow this up. $10 little driver board, which probably cost a pair of gas station sunglasses. So and I've broken plenty of sunglasses in my past. So when I break a pair of cheap sunglasses, I don't feel so bad about it. This is the same price. If this blows up, I don't feel so bad about it either. So I do feel bad when I blow something up that's more than $10. So guys, happy Friday. Just wanted to share this with you. And talk to you guys later. All right.